The leave plan for room subject matter experts has shown that with our new $1.101 billion toy, it is probably going to be some time before things progress true to form. If everything goes as arranged, the excursion to Proxima B will require around 20 years. Anyway, sensibly talking, it may require a couple of years just to affirm if there's any life on that planet. The continuous examination concerning whether we are genuinely single in the universe proceeds, ignited by discoveries from the James Webb Space Telescope, JWST. This telescope has already revealed some amazingly intriguing peculiarities from a long way beyond Earth, perhaps carrying us closer to responding to this well-established question. Our drive to comprehend our place and importance in the universe has forever been major to human instinct, prompting incalculable creations and speculations all through history. Our interest in space, matched with sensations of segregation, constrains us to continue looking for other living things. Even though we are only specks in the vastness of the universe, we might draw closer to the answers we seek. Yet, are they actually the answers we want, or are they simply agitating revelations? Join us as we explore the latest discoveries in the fields of exoplanets and planetary systems, setting out on an excursion that might lead us to confront something we're not yet prepared to understand. In 2021, specialists made a fantastic leap forward, conceivably one of the greatest scientific breakthroughs ever, with the launch of the James Webb Space Telescope. This provoked a captivating speculative inquiry about the power of our technology. Could future telescopes detect artificial light on distant planets like Proxima B, the nearest exoplanet to Earth, found 4.25 light-years away? Proxima B was discovered to have a permanent day side and night side, much like the Moon. A highly advanced civilization on Proxima B could possibly harness energy from the day side and transfer it to the night side using photovoltaic cells that convert sunlight into power. A paper co-written by Manasvi Lingam and other researchers demonstrated that a vast array of solar panels could be placed on the day side, with future telescopes detecting their presence. With the JWST updates, our ability to search for artificial lights on planets like Proxima B has expanded. The fact that JWST was able to detect these lights in 2024, thanks to its enhanced capabilities, marks a revolutionary moment. The JWST could have found the very lights we've been searching for, possibly launching humanity into a new era of exploration. We should dive into the universe of planets and exoplanets to understand how this discovery became a reality. Since the dawn of history, humans have pondered the vastness of the universe, who we are, where we came from, and where we are going. These ageless questions remain exceptionally complex. Despite our technological advancements, we are still left wondering if we are any closer to answers. A scientist might argue that we are currently at the early stages of understanding our role in the universe, while an astronomer would likely be eager to share the latest discoveries made possible through advanced instruments. These instruments, often overlooked by the general public, represent humanity's ongoing progress. We now have access to the universe, and it's time to push forward using the knowledge and technology that bring the cosmos within reach. One of the key advancements in this pursuit is the creation of the James Webb Space Telescope, JWST, a tool that holds the potential to answer some of humanity's most significant questions. The JWST represents humanity's effort to probe the mysteries of space and seek answers to ancient questions. Are we alone? What is our purpose? Where are we heading? This powerful infrared telescope is actively searching for those answers. If you're wondering about Proxima B, it's sometimes called Proxima Centauri B or Alpha Centauri B. This exoplanet is classified as a super-Earth and orbits an M-type star. You may be unfamiliar with the term super-Earth, so let's clarify. Super-Earths are planets that are larger than Earth, but smaller than gas giants like Neptune or Uranus. They can be composed of rock, gas, or a combination of both. These planets range in size from twice Earth's mass to several times that of our planet. Proxima B is one of these super-Earths and, like other exoplanets, orbits beyond our solar system. The first indications of exoplanets appeared in 1917, but it was not until 1992 that the first confirmed discovery astonished scientists. Another exoplanet, initially detected in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems, with 896 systems hosting more than one planet. A significant number of these exoplanets orbit M-type stars. To understand M-type stars, it's important to know that they are the smallest stars in the main sequence and are often called red dwarfs. These stars are widespread in the Milky Way, yet their faint light makes them difficult to detect. M-type stars have temperatures around 3,000 Kelvin, which is relatively cool compared to other stars. Proxima B's host star, Proxima Centauri, has a mass around 1.07 times that of Earth. Interestingly, Proxima B takes only 11.2 days to complete one orbit around its star, much shorter than Earth's 365.25-day orbit. Proxima Centauri is very faint, emitting only 1.6% of the Sun's total visible light output. The majority of its energy is emitted in infrared radiation, accounting for over 85% of the total. Proxima B orbits its star at a distance between 0.045 and 0.056 astronomical units. Much closer than Earth is to the Sun discovered in 2016. Proxima B has garnered significant attention despite the existence of countless other stars, planets, and galaxies. There are several reasons for this. First, it is the closest known exoplanet to our Sun, only 4.2 light-years away. While 4.2 light-years may sound immense, it is relatively close in the grand scheme of the universe. Proxima B is part of the Alpha Centauri system, a triple-star system. Despite Proxima Centauri's faint light, the Alpha Centauri system remains one of the brightest objects in the night sky, following only Sirius and Canopus. Perhaps the most intriguing aspect of Proxima B is its potential habitability. It exists within its star's habitable zone, where liquid water could exist, raising the possibility of life. As a result, astronomers are eager to explore the habitability of Proxima B and other exoplanets like it. This is where the James Webb Space Telescope becomes crucial. The JWST has four primary objectives. 1. Examining the light from the first stars and galaxies formed after the Big Bang. 2. Investigating how stars and planetary systems form. 3. Understanding the development of stars and planets. And 4. Exploring the origins of life. As the JWST continues to study exoplanets like Proxima B, we are drawing closer to achieving these objectives. The search for exoplanets and extraterrestrial life is not just about answering scientific questions. It also reflects human curiosity. Throughout history, humans have been driven by an insatiable desire to explore and understand the universe, both living and inanimate. This curiosity led to the creation of the Search for Extraterrestrial Intelligence, SETI, a long-standing effort to find signs of life beyond Earth. SETI is one of humanity's most ambitious undertakings, akin to a cosmic game of hide-and-seek. If we were to encounter intelligent extraterrestrial life, humanity would face an unprecedented challenge, one that is not just scientific but also philosophical, ethical, and even existential. How should we communicate? Would they perceive reality the way we do? What if their biology, intelligence, or social structures are so different that we struggle to comprehend them? Throughout history, major discoveries have often been met with resistance, fear, or even conflict. The realization that we are not alone in the universe could profoundly reshape our societies, religions, and worldviews. Some might see it as a validation of their beliefs, while others could view it as a threat to human uniqueness. Governments and global institutions would have to decide how to approach such a revelation. Would information be openly shared, or would secrecy prevail, as has often been the case with sensitive discoveries? There is also the question of how extraterrestrial life might perceive us. If they were technologically superior, would they see humanity as a potential ally, a curiosity, or perhaps even a primitive species not yet ready for interstellar interaction? The implications of such contact could be both exhilarating and terrifying. The role of technology in the search for life. Advancements in space technology are rapidly accelerating our ability to search for extraterrestrial life. The James Webb Space Telescope, JWST, has already demonstrated its ability to analyze the atmospheres of exoplanets, detecting potential biosignatures, chemical signs of life. But JWST is just the beginning. Future telescopes, such as the Nancy Grace Roman Space Telescope and the Extremely Large Telescope, JWST, will further enhance our capacity to detect Earth-like planets and study their atmospheres in greater detail. One of the most exciting possibilities is the detection of technosignatures, evidence of advanced alien civilizations. This could include artificial lights, radio signals, large-scale energy usage, or even megastructures such as Dyson spheres, hypothetical constructs that could harness the energy of an entire star. If JWST or its successors were to detect something unmistakably artificial, it would be the most significant discovery in human history. Ethical considerations and the future of contact. If we do find evidence of extraterrestrial life, we must carefully consider how we proceed. Some scientists and philosophers argue that passive observation, simply studying these civilizations without making contact, would be the safest approach. Others advocate for active communication, believing that if intelligent life exists, we should reach out and attempt to establish a dialogue. There is also the risk factor to consider. Throughout history, encounters between civilizations with vastly different levels of technology have often resulted in devastating consequences for the less advanced group. If we were to reach out to an advanced extraterrestrial species, could we be putting ourselves at risk? Some experts, including physicist Stephen Hawking, have warned that broadcasting our existence might attract attention from civilizations that do not have our best interests in mind. On the other hand, if intelligent extraterrestrials are observing us, they might already know we exist. Our radio and television signals have been leaking into space for over a century, traveling at the speed of light. Any civilization within about 100 light-years of Earth might have already received these signals. If they're watching, are they simply waiting for the right moment to respond? The cosmic perspective. Regardless of whether we make contact, the search for extraterrestrial life forces us to confront profound questions about our place in the universe. If we are alone, it raises the question of why life is so rare and what makes Earth so special. If we are not alone, it challenges us to rethink everything we know about life, intelligence, and civilization. In the grand scale of the cosmos, humanity is still in its infancy. Our understanding of the universe is growing, but there is much we have yet to discover. Whether or not we find intelligent life, the search itself is valuable. It drives technological innovation, deepens our philosophical inquiries, and reminds us of the boundless possibilities that exist beyond our world. As telescopes continue to scan the skies and scientists push the boundaries of discovery, one thing is certain: the universe holds more mysteries than we can imagine. And perhaps, one day, we will find the answer to the question that has haunted humanity for centuries. Are we alone? Reasonable becomes integral to how we might interpret our place in the universe. As we proceed to investigate, as we adventure further into the universe, the potential for experiencing extra-earthly insight or life raises both exciting potential outcomes and significant vulnerabilities. The revelation of, indeed, even microbial life somewhere else in the universe would significantly affect how humankind might interpret science, development, and the idea of life itself. It could approve the speculation that life is a typical peculiarity in the universe instead of an interesting mishap. However, the moral and philosophical suggestions would be gigantic. How might we approach creatures from another world? Would it be a good idea for us to endeavor communication, or would that present unanticipated perils? The dangers of defilement, both organic and social, are not trivial. If an encounter with extraterrestrial life were to happen, what protocols would be set up to guarantee the safety of both parties? The situation of finding alien life compels us to confront difficult questions concerning human nature and responsibility. Would our technological superiority grant us the right to intervene or influence the course of extraterrestrial civilizations? Or should we embrace a policy of non-interference? The potential existence of intelligent life elsewhere challenges mankind to rethink its place in the grand scheme of the universe. For centuries, humans have viewed themselves as the apex of life on Earth. Discovering extraterrestrial civilizations could drastically alter this perception, humbling us and forcing us to recognize our own limitations. Likewise, the implications of such discoveries on society would be vast. Mankind's history is marked by instances when the discovery of new frontiers or living beings has caused societal upheaval. The revelation of extraterrestrial life would likely spark an outpouring of social, political, and religious discussions. Many individuals might be excited, others fearful, and some perhaps skeptical or dismissive of the findings. Governments and international bodies would need to collaborate on the best way to handle such information, creating structures for cooperation, regulation, and perhaps even protection. Moreover, the search for extraterrestrial life also addresses existential questions. What does the discovery of life beyond Earth say about our purpose? Are we merely another link in an immense cosmic chain? Or do we have a unique role in the universe? These reflections wouldn't just shape scientific discourse, but would also influence art, philosophy, and culture. Mankind's place in the universe has always been a central theme in literature, film, and art. The reality of extraterrestrial life would inspire new generations of thinkers to reconsider what it means to exist in a universe filled with other sentient beings. On a scientific level, the search for extraterrestrial life offers exciting avenues of exploration. As technology advances, we are increasingly able to potentially identify habitable planets, study their atmospheres, and analyze the chemical signatures of life. Instruments like the James Webb Space Telescope provide the capability to detect biosignatures, such as oxygen, methane, or other compounds, associated with biological processes. The discovery of such signs on distant exoplanets would drive mankind into a new era of scientific inquiry. By examining these exoplanets, we can learn more about the conditions necessary for life to emerge and how life could adapt to environments vastly different from our own. The development of space exploration technologies has also brought the possibility of interstellar travel closer to reality. While current propulsion systems are far from capable of reaching even the nearest stars within a human lifetime, breakthroughs in areas like quantum propulsion or antimatter could one day make interstellar journeys feasible. As we push the boundaries of what is possible, the dream of traveling to planets like Proxima B, or even farther afield, becomes less like science fiction and more like a long-term objective. While Proxima B remains the closest exoplanet that could harbor life, it is far from the only one. The discovery of thousands of exoplanets, many of which lie in the habitable zones of their stars, has expanded the potential for finding life across the galaxy. Some scientists suggest that the sheer number of potentially habitable planets means that life could be common throughout the Milky Way. If this is true, the chances of discovering intelligent life in our lifetime could be higher than previously thought. However, the challenge lies not only in detecting these planets, but in understanding the subtleties of their environments and determining whether conditions are truly suitable for life as we know it. One of the most fascinating possibilities is that life elsewhere in the universe may not resemble anything we recognize. Earth's life is carbon-based, but other forms of life could rely on entirely different biochemical systems. Life on other planets might be silicon-based or could even exist in environments we consider inhospitable, such as gas giants or moons with subsurface oceans. This opens the door to the possibility of life forms that do not conform to our expectations, further broadening our understanding of biology and the adaptability of life. Beyond merely finding life, the search for extraterrestrial intelligence, SETI, continues to spark excitement and speculation. If we were to detect a signal from an advanced civilization, it would not only confirm that we are not alone, but it could also provide an unprecedented opportunity to learn from a more developed species. However, the question remains, are such civilizations out there? And if so, why haven't we received any signals? This is the Fermi paradox, the mystery of why, given the vastness of the universe, we have yet to find any evidence of extraterrestrial civilizations. It may be that intelligent civilizations are rare, or perhaps they are deliberately avoiding contact with us. It's also possible that they rise and fall before we have a chance to detect them. As we push forward into the unknown, one thing is clear. The journey for knowledge about extraterrestrial life is more than just a scientific endeavor. It is a journey of self-discovery. By searching the stars, we seek not only to understand what lies beyond, but also to better understand ourselves. The discovery of alien life, whether microbial or intelligent, would force mankind to confront its place in the universe and challenge the assumptions we hold about our uniqueness. Ultimately, this quest for knowledge is part of a greater journey, one that seeks to answer the questions that have always haunted us. Are we alone? And if not, what does it mean for mankind to share the universe with other beings?